A very warm welcome from the Untitled Chamber here in Bangkok. It's almost 4 p.m. Bangkok time, meaning 5 p.m. Singapore time and 11 a.m. the Netherlands time. We're about to start in a few minutes, so we're asking for your kind patience until we have a few more participants signing up. So a few more minutes and we'll start with today's webinar. Thank you very much. Again, a very warm welcome from the Untitled Chamber here in Bangkok at the Dutch Embassy. A warm welcome to all of you participating in today's webinar. We have started as the Untitled Chamber a series of Industry 4.0 webinars and meetings. And this is already our second edition. And today is all about predictive simulation and digital twin. We will hear everything about these subjects in a few moments. I will keep my introduction very short because we're not here to listen to me. But I would like to review we have started. I saw Frank van Baal joined as well. Actually, as August, where we had our first hybrid session last week. And it was also well attended and the kickoff of, let's say, our NTCC Industry 4.0. Today, we are actually blessed to have our friends of Royal Haskoning, DHV, and our, let's say, keynote speakers, guest speakers, thought leaders are today based in Singapore and also in the Netherlands. The introduction will be done by Ruud Kreuk, and Ruud has already sent some messages to all of you. Ruud will be also today's moderator for this session. And looking at my members who also participated at our Game Changers Award dinner last year, you might remember Ruud as one of the game changers on our stage. So we're very blessed to have you there as well, Ruud. Ruud is currently in Singapore and he will guide us through today's topic. Now, what will be today on the agenda? Actually, this sharing session will emphasize on how leading companies are using these core technologies of the Industry 4.0 revolution to gain new foresight that has previously not been available to decision makers like yourselves. I guess this would be all for a short introduction from my side. So household rules, please ask your questions through the chat functionality. Please try to keep your microphone muted as well as your cameras. Enjoy the session, ask a lot of questions. We have sufficient time scheduled for the Q&A. We'll hope to make it as interactive as possible. So you'll see a few polls in between the presentation. And if you are ready for it, Ruth, I would like to pass basically the microphone and camera to you in Singapore.
Okay, good. You see me?
We can see and hear you loud and clear.
Okay, okay, great, great. And, let's give it a go. Yes, okay, welcome you all. I'm happy to see that we have guests from logistic companies, FMCG, oil and gas from different areas. So it's good to see that you're interested in this topic. First of all, I would like to start with the housekeeping. So the objective for today during this 60-minute session will be to share knowledge about predictive simulation in specific and digital twin in general. We will use a lot of success stories or use cases to show you how firms in the market are using this kind of technology. We hope that we can have like an interactive session. That means that we have built in a few question and answer between the topics. So that gives you some space to ask what's on your mind. All participants will be muted, as Hans said, so we try to use the chat box. You can send it to everyone, or you can send it only to the host. So that's a choice what you can make. In fact, I would be happy if you can share your questions with the audience. And I think it's important to mention that at the end of this session, tomorrow we will send you the slide deck together with some other information, so you don't have to take any screenshot or whatsoever. You just get everything what we showed today. First of all, I would like to introduce myself. My name is Ruud Kreuk. I'm a business development director for Roy Haskoning, and that's the business line digital. I'm active in APAC. At this moment, mainly active remote, as a lot of people have at the moment. And today we have two keynote speakers. One will be Daniel Albrecht. He's also part of the business line digital. He is our manager of the delivery team in APAC. So he works together with our offices in Bangkok, Ho Chi Minh, Jakarta. And he has like a background working for quite some multinationals, a lot of experience on supply chain logistics and business case consultancy. Last but not least, we have Bart Brink. He joins us from the Netherlands. He's our global director for digital twins. And Bart will take the second part of today's session. That will be more about the digital twin concept and the use cases around that. But first, I will start with what is predictive simulation, to give you a little bit of context. And then we deep dive quite fast into the use cases by Daniel. So let's give it a go. First of all, what is predictive simulation? We have here an example. This is an actual factory built in Europe. This is a processing, food processing asset. And what you see is a digital model that represents the physical thing or physical asset, in this case, a food manufacturing plant. And in fact, that is, of course, interesting because we have this visualization. But I think what's more interesting about simulation is that we are able to mimic the behavior and the physical state of this particular thing. And that means that you have like a one-on-one kind of representation of that physical asset. And that is really the power of predictive simulation, but that's something we're going to show later on. Of course, we need data. We need data to feed this model, this simulation. And that can be all kinds of data. It can be forecasting data, let's say sales forecasting to predict your production needs. It can be historical data to use that, in fact, to predict the future. And it can also be real-time data. So it can be combinations, but in the end, it needs to be fed with data. We bring value with predictive simulation by visualization, of course, what you can see here. So with the different stakeholders from operations, supply chain, from the different departments within your organization, you're able to work on this model together. But there is more than that. In fact, this is really useful to do analysis, to do prediction, and really do optimization of your assets. And that's the true value we bring. Last but not least, and this is also together with the second one, a really important one, is that you're able to experiment in time without any investment. And in fact, you are able to predict future without interference of your operation. So you can test scenarios without interfering your actual operations. So I think there are a few attributes that is all about predictive simulation. So what do we try to do with this? We see that our clients, they have all kinds of business questions, and we have here a few of them. And most of those will be answered today by the use cases. But you see from the right to the left in this manufacturing layout, on the right side, you see more the process area. In the middle, more the discrete, let's say filling, packaging kind of activities. And on the left side, you see logistics. So predictive simulation can be used. This technology can be used in combination with the right domain expertise. It can be logistic expertise, can be manufacturing expertise. It can be used in that combination to try to find the right answers to test scenarios. What I think is important to mention as well is that predictive simulation can be used on various ways. On the left side, we have like a more detailed overview of line level simulation. On the right side, we go more to the supply chain. So we not only look at the make part, but also the chain of activities around that. And in the middle, we have an example of a facility level where we look at the flows, logistic, manufacturing within one particular facility. So what you can see here is that on various ways we can use predictive simulation in order to find the answers and bring the right foresight and insight. From here, I would like to give the floor to Daniel, because now we go to the what I like the most, use cases, good examples to open up your mind to start to understand how it can be applicable to you as well, maybe. Daniel?
Thank you, Ruud. Very happy. Let you go on mute there. Thank you, Ruud. Very happy to be here and happy to share with everyone some tangible use cases of indeed where we've used simulation studies to have real impact on client businesses. So first I wanted to start, Ruud, next slide. First, I want to start with a background on a simplified overview for everyone on how does discrete event simulation indeed work. You've seen some videos on the earlier slides. You'll see some more nice videos next, some nice screenshots from the models. But of course, what's important is how does this happen, right? How do we build a model that will accurately represent your operations and help you to answer some questions looking forward, looking backwards. So it starts like most Lean, Six Sigma, most improvement exercises by mapping your process flows, understanding indeed what is really happening here, right? So the truck arrives on the site. Does it have its quality check first, or does it go to the weighbridge? If the parking lot is full, what happens, right? Feedback loops, these kinds of things. It's all about mapping that accurately. Next, you take real business data, right? Real operational data. So you take 6 months worth of data of those truck arrivals onto the site, and you start to understand, are there more truck arrivals on a Monday morning and less on a Friday afternoon, right? Starting to get a feeling of how does that happen over the hours of an operational day, and you build into this and process rules as well, right? So that's the things like feedback loops, the complications of daily business that often aren't captured if you just do static Excel models. From both of those, we create and then validate the simulation model itself. And you see there that can be 2D, that can be 3D, that can be visually representative. It can be just purely right running in a background and only looking at the inputs and the outputs. But you create that model and then you validate together with the stakeholders. Is this an accurate representation of our process? Does it behave like we would expect it to behave? If we break this machine down for a few hours, what happens? Is it as what we expect, right? And we validate by looking at historical data that we feed into the model, comparing the model results to what really happened in real life, and use that as a validation to make sure we're all confident in the quality of that model, and that indeed when we take the next step, which is really the more fun part, experimentation, that you're going to get the right answers when you look forward into the future. So indeed, experimentation is where you release a lot of the value. A lot happens, I should mention, in the earlier steps as well, especially if you're making a major change to your process for the first time, or you're building a greenfield site, or major changes in a brownfield optimization or expansion. Just the experience, as most practitioners will know, of process mapping, of collecting the data, of asking wait a minute, what happens when that is full, when this breaks down, when this, right, in this scenario. Just asking those questions in workshops, and the modeling experience itself naturally needs to bring that out, is a very valuable exercise. But the real fun part is when you start to experiment and you say, can my site handle the volumes 5 years out in the future? What happens if we add this extra line? Or what happens on a network level if we build a new facility, right? That's really the fun part, that's the reporting, and that's where you get the answers to start to help. So keep these in mind as you see the examples on the next slides. Okay, this first one is a project completed in Q1 of 2020 in Japan for a major cosmetic brand. They've got a factory, which you see in the middle, and we don't model the detail of the factory because that was not the core questions for the client in this one. It was very much about the logistics, the warehouse storage, and the outbound operations. So we go there and we black box everything else. You see in the middle is the current production lines, and they had a pallet level ASRS on the right-hand side, and their inbound and outbound docks. Now they were in the great position of having some very significant growth, and they were expanding their facility, putting in some new high-speed lines on the left-hand side, a new case level ASRS, because they have very high value, right, items. They wanted to do more case level shipments and direct from the factory. So they were making this investment. We got brought in to validate the second stage of that investment, which was that they realized we don't have a connection between the left and the right-hand side of this facility. We're going to have to manually move if we want to move SKUs, move storage between the two sides. So they looked at bringing in a conveyor bridge, a raised conveyor bridge to connect the two sides of the platform, some robot palletizers on either side, and a new set of docks that you see in the middle there. So our project started looking particularly at the engineering side, the CapEx side. That's the world that we come from, looking at what's the throughput needed, does this design really work, what's going to be the capacity utilization on these docks, on the conveyor belt, what kind of design requirements do we need to send back to the supplier of this equipment. Interestingly enough, the project then shifted as we got going and started to think about operationally, how are they going to run this facility? How are you going to shift the goods between the different sides? So it really came down to experimenting with their operational model. Do you want weekly replenishment? Do you want daily replenishment? Should that be overnight? Should that be running in the morning? Do you want to have instead the trucks, the outbound trucks, come and visit both sets of docks instead of trying to move the goods to the docks? So some really interesting strategies and experimentations that we ran with the client. Overall, it was a successful exercise. We continue to work with them and continue to use this model today to experiment with COVID, with changes in design, changes in volume. They're looking at some new volume forecasts, now looking at how can we push this CapEx out and how can we extend the life and sweat the assets in the current site. So really nice example there of a brownfield expansion project. Looking at the next one, this one's in the feed mill industry, so the animal health. With this client, they were at a much earlier stage. So they're in the master plan phase. They're designing this as a generic master plan to put into use across Asia and Africa, okay, for their facilities. They want most of their facilities to follow the same master plan with, of course, local tweaks to the capacities needed to the local requirements and processes. They had in mind two particular ways of setting up this master plan, particularly the entrance and gate part of the process. And they had some concerns about how it was set up today and potential bottlenecks at the weighbridge and at the entrance itself, and some safety issues coming out of those finished good docks you see there with the grade trucks. So for this client, we did a rather, let's say, rapid fire project, so about 4 to 5 week total timeline. built the model, as you see here, over their drawings, brought in real-world data from one of their sites in Myanmar, looking at, again, 6 months data of their actual truck arrivals. What are the patterns? What kind of volumes do you expect at different times? And started to then compare that and build a second model with their alternative layout, with a more roundabout in the entrance, which really removed that bottleneck. This was a great exercise for them to indeed have to take a more data-driven approach to validate which of these two options is better, right? Everybody has experience, gut feelings that they bring to the table. There were some debates happening internally, but when you really run this exercise, put some data in front of everybody and show, option B, the alternative can handle, it was about 20–30% more throughput by removing this bottleneck at the weighbridge and at the entrance. That was a really powerful exercise, right, to bring that data to the table. With this, they're able to make some tweaks to that master plan, indeed go ahead with the alternative, but also, again, continue to make improvements on that. And the idea here is indeed to use this as an asset for the organization. So what we do on these kind of projects is build a graphical user interface in a very simple Excel spreadsheet. Everybody's familiar with Excel, a lot less scary than getting into the modeling and the coding that happens here. So for each site, they have the controllable parameters, right? Which is we have one weighbridge, we have two, we have this many parking spots, we have this many finished good docks, we have this arrival pattern or this kind of volume that we want to put through the site. And it's a matter of changing that in the Excel. And then if they have the software behind that, it runs through and it feeds directly to the graphs that then say, well, this is now your utilization, this is your throughput, this is what's happening on your site. So with that, you can imagine it really makes the experimentation piece much more user-friendly and allows it to be integrated more into the daily operations of the company. Next one, now we go down to the process level, right? So the asset or process level that you saw earlier. This one is a confectionery company, one of the top global confectionery companies. Don't have a nice video for you here, but we've got a screenshot of the process. And here you see that indeed this is not visually representative, right? It wasn't going to add value to get exact differences of where all of these tanks and piping is located, or what it looks like. But what was important was understanding the connections, right? Between all of these, what are their capacities? What are the complexities? So this client was looking at making an expansion in this particular facility, looking to debottleneck and increase the capacity to handle some future growth within that site. So they had some ideas of how they could increase that flexibility, more piping, right, to connect certain holding tanks with filling lines, increase some certain capacity in some parts of their process. So you see here, right, like most continuous food processes, you've got what goes into chocolate, right? Sugar, cocoa, vanilla, you've got all your ingredients coming in, right? They start to feed into the conches. Likewise, you have ovens, baking process, extruders, right? All of that then feeds into holding tanks, into line tanks, mixers, and then down to the production lines. So all of this is mapped in the model, also with the real world operational complexity. So this kind of tank can handle this kind of a process. If you're running recipe A, it has a mixing time of 2 hours. If you're running recipe B, it has a mixing time of 4 hours. You never run recipe B and recipe C after each other, right? Because you need a 4-hour clean. So these kinds of realities, right, of operational and production planning are built into the model, and then they allow the client to model their current scenario, get insights into that, and then also model that future scenario. What if we increase the capacity of these tanks, connect with some more piping, this production line Z to line tank X, right? Experiment with these kinds of scenarios. Now in this one, what they were able to do was indeed realize that planned investment in the pipe work, in the expansion on the holding tank would not provide the benefit that they expected. Indeed, it just moves the bottleneck a little bit, somewhere else in that process. So they're able to avoid 350,000 euro capex in this particular case. The production planners continuously use this asset to test S&OP forecasts for the plant. So it's a bit of an early warning system, right? To in a more detailed model. Again, I've worked in some of these companies, and we do the planning, you're doing it in Excel spreadsheets, which again gets you 80–90% of the way there. But I think we all have examples of where it in theory fits into the model and into the plan, but in reality there's a lot more challenges. So that's an example of that one. And one more to tie it all together with engineering. We're an engineering company. So how does that work from an end-to-end perspective? This client was in South Korea. They came with a problem statement of they had a site that used to be a factory. They've pulled all the lines out of that and have been using it as a distribution center for the country. Of course, that's not purpose-built, right? That's not the most efficient setup. So they've decided, yes, we're going to go ahead with this plan. We're not going to build a new one. That's the strategic planning piece. And now they say, how do we invest? How do we transform this old factory into an efficient distribution center? So first we came in and did what we call logistics consultancy. So that's really just looking at their overall flows on the site. What will be the needs? What will be the needs 5 years from now? What are your capacity requirements? What are the different technologies we can bring in here, right? You can bring in an ASRS, you can bring in different types of racking. The workshop approach, right? To explore design and automation opportunities to get them to the future state. Our engineering teams then came in and we did a master plan design. So that's 4 different layouts, various levels of high CapEx, low CapEx, right? Higher storage, lower storage, to help them through. Here are some options in terms of flow, in terms of CapEx, and narrow it down to one particular option that the client wanted to move forward with. And after that, we came in with a simulation study, because simulation is a great tool to use, right? To answer certain questions. At that early stage, it wasn't the right tool to use because we needed to diverge, right? We needed to brainstorm, and you want to test a lot of different options at higher level, and you can get those quick answers. So after that, came in and did the simulation model that you see in the picture there. Next slide. Last piece I'll close on here would be, as you've heard and as you've seen in these examples, there are different opportunities to use simulation in different stages of an asset lifecycle and in an engineering process. So when you're in that early stage in master planning and strategic planning, it's all about, is that project justified, right? Are there better options, supply chain level questions? You get to concept, and it's about looking at testing the capacities, testing different material flows. In basic design, it might be about, okay, now we've got a really good idea. What about these different piping connections? What about different capacities? Are we over, under designed? Once you get into detailed design, you don't want to reopen a lot of those boxes from earlier. And it's often about stress testing, right? Before I'm procuring, before I'm building, I want to really stress test. What am I worried about? What keeps me up at night? And then as you get into the final stage, build, operate, it's really often there about looking forward to operations, experimenting with the different operational strategies like we saw in the Japan example. So thank you very much, folks. Look forward to hearing your questions.
Yes, Daniel, thank you very much. Before we go into the questions, we have like a quick poll. The question here would be like, what would be your key reason to use predictive simulation? So yeah, I give you some time to fill it up. And yeah, let's see what will be the most of the reactions. We see at least. I give it a few extra more seconds. Okay, good. So you see quite diverse. Yeah, Daniel, do you have anything to add on this poll?
Sorry about that. Just see the results coming up now. No, I think yeah. So we got about a quarter across the middle 3 there. Certainly a bit more, or I'd say 50-50 split here in terms of in the CapEx phase. Indeed, right, in that planning and the engineering side of things, making sure, and often de-risking is your main objective there. And then you've got the operational side. These are the assets that we have. What are the different strategies we want to use? And how do we squeeze more? How do I sweat these assets? How do I get more out of it? I think we'll see, and we are seeing definitely a push towards that strategy, right? Especially now in this environment. How do I sweat my assets? How do I get more out of it? Not a lot of boards are approving a lot of the really big investments with the uncertainty that we see. So it makes a lot of sense to me.
Okay, thank you very much. Yeah, I think we can go to the question and answers, and I received a few of them by the host and also by everyone. Let me go back to the first one. What questions do you ask that will help resolve the information requirements for digital twin integration of the supply chain?
Sorry, can you repeat that question? What kind of questions do you need to ask?
Yeah, from Breyer, I wanted to know what questions do you ask the client to help obtain all the necessary information and data before conducting the digital twin or like the simulation to optimize the supply chain. So what kind of questions, what kind of data you are trying to receive?
Yeah. No, so indeed, you start like with most projects, right? You start at the higher level and you say, what are the objectives that we want to achieve here? We call it, what are the exam questions, right? Is it, how do I reduce this process time? How do I reduce inventory? Is this the right place to invest, right? You start with that. We always try to really do a good job of scoping these, right? You might be tempted to try to answer a lot of different questions at once and go very broad with a model, but often what's best here is really choosing the right answers, looking forward at how you want to use that model in the future, and then building the model to the appropriate level of detail, right? You often don't need to get down to every step in that process. You need the right level of detail to answer the question that you have at hand. So it really is a process that starts with that first objective, and then it's a bit of a waterfall down from there. Okay, clear. And also from Stephen, that's like about like, do you influence the size of the plot, what you buy or lease by this predictive simulation process? And that one I think I can answer because we have indeed examples where a client, after they have done the simulation and know what the operations needs, if you look at the sizing, that based on that they know also what kind of plot size they need to buy for now, but also for future, for the expansion they are expecting based on the forecasting. So we have that example. The one I showed at the beginning, that was the food processing or vegetable processing model I showed earlier. That is a good example where the client first started with the operations, and based on that they knew exactly what kind of plot size they were that they needed. So I think that, yeah, good question. I also received this one. Yeah, Daniel, can you share like some OPEX, CAPEX savings that you have realized during the projects, specifically in APAC? Maybe you have like one example of those. Sure. A project that we didn't show here, but one that was completed last year in the Philippines, also for an FMCG company. We're looking at a couple of different ways, again, material transfer. They were looking at putting in a conveyor to connect their factory and their DC across a road. They were looking at investing in 2 conveyors. We were able to show, again, in a more data-driven way, take the emotion out of the decision. They were looking at, we need one each way in backup, right? What happens if this breaks down? We're going to be out of business. But when you really bring the data to the table and show 99.x% time, you're okay. And with these downtimes, you can easily shift to the shuttle trucks. You're able to put the facts on the table and show, guys, you will be okay with one. And they were able to reduce that capex on that conveyor.
Okay. I see one other one coming in. Like, what kind of software tools? I think we should keep this short because we want to continue with Bart. But maybe you can answer this one as well. What kind of software tools we use in this kind of project?
Yeah, so we use. There's a number of discrete event simulation softwares out there on the market. We'll use. Royal Haskoning has one in-house that we'll use. It's called Witness. That's been on the market. One of the leaders in simulation software for quite a while. We also use Flexim. You see some of the videos there in Flexim as well. So we'll change the tool as appropriate for the project. Okay, great. Yeah, I would like to give the floor to Bart if he would like to show face, and he does. Then
Welcome.
Thank you. Shall I take over the screen, Ruud, that I can put the button?
Yeah, please do.
Yeah. Oh, is it disabled? Otherwise, disabled. Let's do. Then you have to do it for me. Let's see now. Okay, I will. So if you can press the button for me when I say the next one, then it's fine. Now, after this introduction story about predictive simulation as a technology and a topic really helping in the Industry 4.0 area, I would like, in the story of digital twins, zoom out a little bit. And digital twins is a concept that is becoming more prominent in the market over the last couple of years, and we see it increasingly being talked about as a part of the digital transformation we see around us in industries, but also in all kinds of sectors. And the digital twin as such is not is a concept. It's not a technology in itself, and I will elaborate a little bit on that, but it's really a concept about how do I create a virtual replica of the physical world, and how can I use that to make better informed decisions. In that regard, digital twins, in my view, are really part of your digital transformation. It's one of those topics, next to others, which really can help you to take steps in becoming more data and digital mature. It helps you to, in the end, make better business decisions, but it also helps you to identify what are the right technologies to use to really get that going. So then a little bit on the digital twin as a concept itself. What is it about? And this is on this slide. And there are multiple definitions of it. So I want to take you on a journey about our view on it. In essence, digital twins are a virtual replica of the physical. Previous slide, Ruud, still. Can you move back?
Bart, you should be able to go through the slides yourself. You are now also co-host.
Yeah. Can you share? Do you see my screen now?
Yes.
It works in the presentation mode as well, Hans? Yeah. Apologies.
Everything is running. Yeah.
Excellent, thank you. That helps a little bit. Now, so what a digital twin does in itself, in essence, is two things. On one end, it gives you an actionable insight about what's happening in the physical world in a virtual form. So it does capture data. And depending on the topic you want to focus on, that can be static data about an asset, but also can be dynamic data collected through IoT, for example, what's happening in a factory, in your operations, but also can be other data. But it's really about capturing that data about the physical environment and describe and give that meaning and show that in a digital twin environment. And that really helps you to raise situational awareness. And purpose one of digital twins is to know what's happening in a certain situation, in a certain context, at a certain moment. Secondly, that basis of a digital twin can be used to predict and design the future world. That can really be about prediction, and their simulation plays a key role, as just highlighted by Daniel. But also can be used to identify how can we optimize and further improve the physical world. What could be ways of changing that? So then you get in the world of AI, machine learning, algorithms. In the end, towards the second purpose of a digital twin is help you to make better informed decisions, and to really help you to know, based on the data, what is the best choice to make in this context, in this business problem. And in the end, to implement it back into the physical world, to change a setting, to change the design, to change the setup on operations, factory, or even supply chain level. That is in essence the concept of digital twin is about. And we see, though, that there are two kind of side effects or a related concept to this essence of digital twin concept, where you have a physical object or situation or context, and you have the virtual replica of it. You see that on one end can be used to really predict and prescribe. So you don't have an existing situation yet, but you model a future scenario and then use that future model to run all kind of simulation scenarios, as predictive simulation examples Daniel was talking about showcase. Next to that, we also see that next to the simulation part, we see increasingly that digital twins are being seen and adopted in the design phase. Already in the design phase, model the virtual replica and the BIM model you have, and add data to that to really de-risk the investment. So that also relates partly to predictive simulation. As said, digital twins bring together, is another technology in itself, but they really bring together all kinds of technologies out there. It's on one hand to capture data. It's about collecting historical data, IoT data, and other sources. It's about dashboarding, visualization of that, not only in dashboards but also into VR and AR. Predictive simulation, AI, and machine learning are increasingly relevant and needed to help let the digital twin become smart and learn. And of course, in the change element, that in the end, digital twins can really take over, not only alert, but also take over decision making and really automate that response in more advanced versions. So I think that is important to understand, and therefore digital twin is more an overarching concept to help to define kind of create a roadmap of change to use the power of data and digital in your business. Having said so, crucial for digital twins is that it always should start. It has multiple levels of how it sits. There is not such a thing as the digital twin. It fully depends about what is your business question. What is the problem you want to solve? So one dimension in there is that you can have a digital twin on an asset level. For example, a pump. I have a digital twin of a pump or a piece of equipment. But you also can have it of a production line or a process level. So that's really about the logistical flows. Now, simulation plays a key part. But even you can go up into the more an ecosystem, on a supply chain, in a country or a city. So that's important. Depending on the business question, you can have a digital twin on multiple levels. Crucial then is always that you, in the end, if you want to build a digital twins in time for your operations or your organization, really make sure that you do that in a consistent manner. That's really about interoperability. So exchange of data and what formats you use. It's really about security. How do you make sure data is being used in the right way and stored in the right way? So that's crucial to take that into account to design in your digital twin strategy and implementation. Secondly, we see across the market various maturity levels if it comes to digital twins. On one end, organizations quite advanced in the digital maturity, really being used to use data already in the decision making, using AI and predictive simulation model as in their operations. You see that they are using more advanced versions of digital twins, really kind of running their factory for them. While on the other hand, we see in other sectors just starting to pick up the concept. Let's take real estate, less mature in digital transformation, take those first steps and much more focus on the getting situational awareness, start collecting relevant data into dashboards or insights to make better informed decisions. The last part is that you can use digital twins at all parts of the life cycle. As with predictive simulation as well, you can do it in the design phase, in the operations phase, but it creates a kind of environment of continuous improvement. So by creating these systems and adding more data to it, combined with domain knowledge and combined with your understanding of your business, and you gradually build up that digital twin of your operations and your organization. Digital twins can be used in all kind of environments. So although you see, and the majority of the attendees is in the industry, digital twins are seen and being adopted in all kind of use cases or sectors. Yes, you can use it in asset management. Really about create a digital twin of a pump and then use digital twins and the data it's used and the smart things around it to look at maintenance, how to optimize that, how to create algorithms to manage that and help you to make better informed decisions. But you also can see it in more dynamic environments. For example, around traffic or monitor people flows in your factory, especially relevant with COVID these days, or water management. Really managing water flows and create a digital twin of that environment. Energy processes. So there is digital twins are not only industry active, but you see across those verticals, increasingly the concept being adopted, and the learnings how to do that and what is critical for success are kind of similar across these sectors. Because things to be successful with digital twins is, as I said, it's part of a journey. It's a digital transformation. So it's not about, it should be interoperable. It's about driven by data. So it's really important that you as part of your digital twin adaptation, look at data, what is relevant data, that you collect the relevant data, that you make sure it's right. But it's also about a change for your organization, because if you start adopting digital twins in your operations, that also means that people get other information to them, or the way they participate or do their daily activities change. So these are topics you need to take in your mind when you get into the digital twin opportunity or transformation space and start working on these kind of concepts. Now, to also cautious of time, and I want to be allowed enough time for questions. I have some examples. I will highlight 2 or 3 of them. There are, with information that will be provided afterward, we worked out several of these customer stories in far more detail on our website. So I think if you want to know more on these examples, go through them. They explain in the detail like Daniel did about it. But let's take some of them for now. Example 1, which I want to share, which is outside most of your industry, but everybody can familiarize with them. With this one is in the aviation environment at Schiphol Airport, our main hub in the Netherlands and Amsterdam. And what we did there is kind of look at airport terminals, so the place where people embark on an airport. The challenge, the business question there is often, this is the most critical moment next to security control in your journey towards an airplane. So you have to wait for 2 hours to embark that airplane, and then comfort. How do I feel? What is the temperature around me? What is the humidity around me? Is a quite a critical element. Traditionally, what we always do there, if we design airports, is use all kind of HVAC related technologies to measure CO2 and optimize that. But what we did with Schiphol in this case is that we start collecting other data sources to it. So what we in the end created was a digital twin of that terminal by collecting information from the flight information system about the number of passengers and the moment they depart, combined with the climate system. So the climate system exactly knew how many people will be there at a certain moment, and we added domain-rich models to that about if we know that in 3 hours this airplane will depart, we now have to increase the airflow into that terminal. And that way it's created a kind of an iterative model of the airport terminal on climate. Doing so, we created kind of a digital twin of that environment and a self-learning environment to continuously improve it, because we did measure as well, in fact, what is the humidity then in practice? Does it work? And then through Wi-Fi sniffling, understand how many people were actually there and where were they. So that was a simple example of a digital twin that was created around that specific business question. Clearly, comfort went up, cost went down, and traveler satisfaction went up. Another one is a little bit more in the predictive simulation space. I don't want to cover the predictive simulation part, but what happened in this case, where they used predictive simulation initially in the design phase, that it was later on not also used in the real operations. So it was really integrated into Epicor's ERP systems. So really using live, real-time relevant data to continuously keep updating the model and keep running it to further optimize operations. Now, this is an example which we have much more detailed on our website, but I think it's an example where we did this. Another one, and as I said, in a more mature market, is the automotive sector. And there you see that they also create these digital twin systems where they continuously start collecting data to feed into the digital twins they created and continuously use them for all kind of business questions. And they do a lot of this, but also increasingly in that way find the sweet spot about how to further optimize planning, how to further optimize scheduling, how to better make use of that and start not only by simulation, but create a learning environment and make an increasingly smarter digital twins, which help them to make better informed decisions, but also create AI trained algorithms to help them to always find the optimized point between planning, costs in a volatile environment. A little bit outside industry, one I would like to, which is also a use case we have on our website, is that, and it gives us a lot of learning environment, is the water sector, where you see that we see that water flows and the quality of water is quite, there's quite an opportunity to help in managing that using digital twins by collecting data, analyzing data, but also using algorithms to identify where is that sweet spot. So what we did with AquaSuite, which is a software solution to do that, which is running in Singapore, in the UK, in the Netherlands, and 70% of the water treatment facilities, is really using domain knowledge about water treatment, put it into algorithms, and then continuously find that sweet spot of water treatment in that situation. So another one that shows that we really can use the digital twins, bring together domain knowledge, data and digital technology, and to really help you to solve business problems. The last one, but I will keep this really brief, which is also on the website, a little bit more advanced one about logistics. This is really next to simulation and AI. This is really a good example where you can see if we combine these technologies like data science, AI, and simulation to really look for the right data with the right information, and that to train your models has a lot of potential. Now, to round off, crucial with digital twins is that you see it, as I discussed, start from the business question. Really know what is your challenge at hand, what is the value you want to create, what is the use case you want to solve, and then look at the right technology. As said, it's not a technology first, but a technology enabled topic. We can help you with that. Read it for yourself. We have quite a portfolio, not only for predictive simulation and solutions in that space, but also data science, digital transformation expertise, and understanding of, as engineers, about the physical environment. And last but not least, in the action, to take this forward, it's always about start with your journey in mind and know what the problem is to solve. Always, it should be a business-led initiative. Start making small steps, take a small example and work from that. So don't think big, act small. And it's about an ecosystem in the end, but gradually start building that. That was my part for now. Then I take back to you, Ruud.
Then yeah, also here we are like quite curious, and we have the question like, at what stage is your company in regard to digital twin? And yeah, please be honest, because we know this is quite new. So we have 5 different stages here. Oh, this looks pretty, I'm quite curious about some use in everyday operations. Like you can just drop how you use it in the chat box if you want. Okay, Bart, so is this something you are expecting?
No, I think yes, I'm expecting. I think digital twins is kind of a new kid on the block, although it's there for a couple of years, and it also has a marketing buzz around it. Let's be fair, a lot of people start talking about it. It's also quite new as a concept. So the fact that it's not being considered yet as a topic versus that some already use it, I think it is in line with what I expect. So people are, not every company is in the same part of the digital transformation, and not everybody. It is also about the start. How far are they? And secondly, also what is the terminology they use and what is the definitions they use for certain areas. So I think important in the digital twin environment is important that we get clarity about what is it about, that there's a common understanding there, but also increasingly I think it's a new topic. But just by starting using predictive simulation already takes first steps in that journey. So I think for me, this is in line with expectations, and I see those differences. And the more mature you get new challenges as well. So it's in line with what I see in the market. Yeah.
Okay. Great. Then yeah, let's go for the questions. Maybe you can go to the next visual, Bart.
Yeah.
Okay. Question and answers. I received as host a question like, Bart, what do you expect? Where is the most value for digital twins? Is it at asset level, process level, or enterprise level?
Silly answer and simple answer. It really depends on the use case you have. Though I think on asset level, in a lot of cases, it's more close. So you have a clear focus. In building your ecosystem and digital twins, I think start with the asset level and then move up, or the process level. I think in the end, if you do that thoroughly and you identify where is the highest value for the leastest impact cost, so what is that sweet spot to find, and then build gradually it up. So I think in the end, if you have for your whole organization a digital twin, it's much more the more you get into I wouldn't say in the end value is, of course, if you have a digital twin of your whole supply chain, there is the most value, but you have to gradually build it up. So that would be my take. So in the end, on asset and process level, there's a lot to gain. I would also advise to start there, but in the end, it will grow gradually up there. And it's that combination and that ecosystem. Yeah.
Okay. From Brian, like, do you have any examples of digital twin applied to optimize the logistic of the construction sector?
Not our, I think that is a use case of digital twins in general. So it's also a topic where I see across the world, which I'm discussing with all kind of other players out there as well, which increasingly is a use case being looked at. For ourselves as RTHV, we as an engineering consultant, we didn't get too active yet in that specific question as far as I'm aware. So simply said, no, we don't have personal experience, but a lot of the learnings I just shared can be applied there. It's one of those use cases I see increasingly being quoted since the engineering and the construction sector is starting to adopt digital twins. Initially, it was really driven in the operational phase, but now I see much more that construction companies, engineering consultants are picking this topic up as well. And that is one of those areas they look into, but we don't have that experience yet in that specific case. But a lot of the things showed by Daniel can be applied as well about the site logistics for building it up. Yeah.
Okay, clear. Yeah, I read recently about an example of infrastructure project where they first built this digital twin in design phase and then start to use it for the construction of that specific tunnel. There was a project in Europe.
That's one, and another one I'm aware of is that Bentley did a project in America with Bentley iTwin Solutions as a technology, where they did this. So there are examples out there. Bentley is one of them. Yeah.
Yeah. And I think also, if I can say, Bart, if you look at BIM, has also a certain functionality for your planning and the flows of your material inventory to manage that in the right order, changes, and to directly interact with the site. I think there's also, I think, an interesting example.
So maybe one small remark on that one is that BIM is, in my perception, really the foundation for digital twins. So by you applying BIM in the design process and organize your information, because that's the essence of BIM. It's not about a 3D model, but it's about a proper information process of identifying, starting, collecting, and bringing together the right data to build in the end and operate after that. That really brings a foundation for digital twins next to that, after that. So these concepts are related. Yeah.
Yeah. I see you're also an interesting one. What software do you use for digital twin?
No, I think again back to the in digital twins, depending on the use case, you have to bring together technology. And on one end, that can be predictive simulation software. Again, Witness, Flexim. Secondly, you see that on the asset management layer, you see that there is quite some technology out there. It's not per se software, it's more IoT platforms in the likes of Aviva, Schneider, Mindsphere, Predix. So we know all these technologies out there which can help you to build that part of the digital twin. Where we ourselves focus predominantly on is not on those generic, basic, crucial, relevant information. You need to have to start collecting your data and have it in the same environment, but start creating value on top of that. So adding the domain knowledge about what our business question and what kind of algorithms can we develop to solve those challenges. So digital twin is really about an ecosystem approach, identifying what is your business challenge and what you want to solve, and then look for the right technology to do that.
Okay. Thank you. And we have 2 minutes left. I think I want to go to the last of the visuals. So I'm gonna give the floor to Hans in a bit. But first of all, I would like to thank the attendees. And looking at the group we started with, around 35, I think we have now 32. So I think we have like quite a stable group that was interested in this topic, I hope. If you have any comments or any feedback, we will send tomorrow an email including the slide deck. We have the context of our APAC team if you are interested to continue this conversation. And what Bart already mentioned, we will also add certain articles and links to get more informed about this specific topic. Yeah, thank you very much for listening. And I would like to give the floor to Hans.
Well, a huge thank to you, the three of you, Royal Haskoning friends. Really, this was really enlightening. And I think looking at the comments, it was also very interactive. So thank you very much. And this actually concludes the second edition of our series, Manufacturing Industry 4.0 of the Netherlands Chamber of Commerce. When we started this series and asked for feedback on topics, it was, we wanted to know more about or gain knowledge on digitization. Well, I think today it ticks that box very nicely. As Ruud already mentioned, tomorrow you will be sending out the information and more questions you might have, please send to us. We're more than happy to refer them to Ruud and the colleagues. So a big thank you again. And please stay tuned and write down already 10th of September for the third edition of the NTCC webinar series of the Industry 4.0. Then we'll hear everything about mechatronics applied. Not a term which might not be familiar with everyone. This will be conducted by our friends from Kirlos Car Brothers, and that will be also including a field inspection at one of the BMA pumps sites actually here in the north part of Bangkok. An interesting session, I would say. But now, for now, a great thank you to our three guest speakers and hosts, and a huge thank for the audience for staying along. And I wish you all a very nice remainder of the day and a very nice evening in this part of the world. Thank you very much. Bye.
Bye.
Thank you.